All right, so here is my improvised solution to number 33. I look at the left and I see that I've got this sum of angles and this difference of angles over there. And I really don't want that because on the right there's just plain angles and plain angles. So I'm going to do the formula, and that's going to get rid of all that plus inside the sine stuff. So what that means is that I have to sing myself a little song. This is a sine problem, so I'm going to do sine, cosine, and a cosine, sine. And then on the bottom, I'm also going to have a sine, cosine, and a cosine, sine. And the angles go alpha, beta, alpha, beta, alpha, beta, alpha, beta. But on the top, it was a plus, and on the bottom, it's a minus because sine is polite and does what it's told. All right, so I look at this, and if you pull back and look at it from 50,000 feet, I see that I've got 1, 2, 3, 4 parts. And really, that's not bad because on the right, I've got 1, 2, 3, 4 parts as well. So that's actually what I want. I am now just going to concentrate on making this top left part turn into that top left part. And clearly the way to get 1 is to divide by yourself. So that means that I'm going to take this whole problem and write that I've got sine alpha cos beta plus cos alpha sine beta. And I'm going to leave myself a bunch of room because I'm about to divide. And who's afraid of fractions? Not me. Cos alpha sine beta. And now let us divide. Holy shnikes. By sine alpha cos beta. But whatever you do to one thing in a fraction, you got to do to all the things. Sine alpha cos beta, sine alpha cos beta. Oh my gosh, what did I just do? Okay, so this one up here is just 1. That was how we designed this. We wanted it to be 1 up there, so that's going to be a 1. And then here I need to just regard the alphas at a time. So this is a cosine over a sine, and it's called a quotient identity. It's when things are divided. What is that equal to? What is cosine over sine? Well, that's one of the 2 definitions of cotangent, of cot. And then in the next part over there, I've got, for the betas, I've got sine over cosine. Well, that is the definition of tangent. So that's how that went. Bottom left, I've also got a 1. Again, I've got, for the alphas, I've got the definition of cot. And for the tangents, for beta, I've got a tangent. And now the left side looks like the right.